Okay, but great. I hope you see the slide now, building your first Lightning web application. And I think it's actually easier to build a Lightning web application than to get a conference and screen sharing working in these days. So that was a super cool overview of Roy. I learned a lot, and it's actually great to see what is going on there. In my talk today, I also want to give you a quick overview about what you need to build a Lightning web application, and then we actually will look into code. So please also post your questions on code. Check out the GitHub repository that I will share, and yep, I will directly take the questions then. Quick word to me. My name is Michael. In the webs, I'm called Bumi. You find me on Twitter, on GitHub with that handle. I'm actually right now working on Alby, the Lightning wallet for the web. So we try to build this bridge between the user's Lightning node, the user's Lightning wallet, and any web application, with the goal to make this integration as seamless as possible. You find more information on that one on getalby.com. You will also find the link to GitHub and everything that you need there. But let's get right into that. What do we have right now? And this is what I'm super excited about because we got such amazing building blocks there with Bitcoin and the Lightning Network now. So we got the best monetary unit with Bitcoin, the currency, becoming a real global trade and settlement currency with hard money. We got the Bitcoin network, the decentralized permissionless network. I don't have to ask a payment service provider to participate. I can just run software, and it's open, censorship resistant, and global. We got the Lightning Network now as a scalable solution to scale the payment network. As Roy just mentioned, it's important that we now use that scaling and create a lot of transactions. And for us developers, we now got more and more developer tools coming up that are now super usable. We got LSPs, as we just seen, and a lot of protocols, libraries that really make it much easier to build on top of all these kind of things. And for the user, we have more and more usable wallets. The Lightning Network is now on all the platforms that you basically can imagine, like the desktop, but also integrated in all these different mobile apps. And if we put that on a layer, actually, then we can say we have like the basic internet infrastructure that we're building on top of that. So that's the TCP/IP protocol. That's the HTTP. On top of that, we have the layer 1 network, the Bitcoin, the network, and Bitcoin, the currency. On top of that, we now have the layer 2 network, the Lightning Network, to scale layer 1 as a scaling solution for the layer 1. And then we now have on, maybe some call it layer 2.5, a lot of Lightning tools and services, like the LSPs. And on top of that, we now have the more and more coming up, the Lightning application layer. And this is the kind of the layer where we are now working. So we kind of can build on top of all these existing tools and existing protocols and layers to create completely new kinds of applications. And we can also see that in the different tools and companies and products that are out there. We have as a core really the Bitcoin core, the Bitcoin network. We have there, for example, also the hardware wallets that are really close to Bitcoin network. On top of that, we have the different Lightning implementations, LND, Eclair, C Lightning, etc. There are a bunch of more, LDK as should be mentioned here. And on top of that, we then have different kinds of companies providing applications and services. That's also wallet tools like Suse, Breeze. We have products like Galoy, or tools like LNbits that you can use in your stack. And we have then also, I mentioned Alby and the whole product suite that Synonym is providing. And all these tools we can use now on the application layer and integrate and build on top of that. And what I like in the setup of Lightning is that, or in the setup of Bitcoin is that on the lower levels, we have a lot of stability. The Bitcoin network is very, very stable. It has proven for many years now to be like the stable network. And the higher we go, we get more and more innovation and possibilities for innovations, more and more specialized tools and products that can be built and can use all the underlying layers, which I think is quite unique in the Bitcoin ecosystem as compared to some of the other networks, and that's why I'm also like super bullish on building anything on the Lightning network, because we have this like super stable, proven foundation that we can use. As I mentioned, even though we talk a lot about payments, all these applications that you can build are not only for payments. Roy mentioned, for example, LNC as a tool, and also Alby is working towards that, that exposes more APIs to not only perform payments more or less on the network, but do anything that you can imagine with the Lightning network, from signing messages also to, for example, to managing channels and so on. But we here focus now on the payments. And some of you might have read the HTTP standard from, I think, 1999. Something like that. And we now have all these HTTP status codes, like, for example, 401 unauthorized, or 403 forbidden, that you all might have already seen probably. But there is also the 402 payment required status code. And the spec actually says this code is reserved for future use. And this was the case because I would say we didn't have the tools and the protocols to build an open network back then when the spec was written. But the authors definitely envisioned a web that has native payments enabled. And I think, as we see, this future is really now. The Lightning network really brings the missing piece to the web and allows us now to really have native payments directly in the web. How does a typical architecture look for your applications? So obviously, we have the user in between. We have some kind of a UI. That's typically then your web application. The awesome part here is now that we are at the state where we can use the full stack of web technologies, HTML, JavaScript. The app runs in the browser. And this is probably the best technology, the most widest used technology that allows you to iterate fast and build products really fast. For that, as we also have seen in the talk before, you need some kind of a Lightning backend, potentially to talk to the Lightning node, which is then connected to the Lightning network. So this is you as a developer side. The user then obviously also has a wallet that is connected to the Lightning node. And this is where it comes together. But this is also a difference to existing applications. You have like these two sides now. The user has a wallet, user performs actions in a wallet. The actions are, like, for example, the payment is sent through the Lightning Network, and from there, your applications receives it. In your typical web application without Lightning, you would basically only have like the user interacting with your app, but this is something now that you have to consider. And keep in mind that your application basically calls the wallet of the user, and the user performs the action, which then goes through the Lightning Network, and from there gets to your application. And often for your app, we have to think about what is the payment flow, how to get the payment details, how to validate the payment. So this is the important part, and probably whatever your idea is, the first questions that you have to ask. As we've seen a bit with the questions that we had before, it always depends on the use case what you want to do. But first, you have to think about the payment flow and how to orchestrate the payment flow, what payment details are needed for that. Some of the protocols that help you with that, we've seen before. I quickly also run through those. We have LNURL, which is basically a set of standard to make it possible to achieve really great Lightning user experience. Some of the standards are LNURL Pay, which basically answers the question how to receive Lightning details, a payment request from a recipient. We have LNURL Withdraw, which answers the question how to withdraw funds from a service to a Lightning wallet. But we also have standards like LNURL Auth, which answers the question how to authenticate using the user's Lightning wallet against the web application. And the nice thing here is that these spec are using standard web technologies. So that's HTTP and JSON. So this is very much known to any web developer. It's basically just doing an HTTP call and parsing some JSON. I have here down here 2 examples basically for you, and this is an LNURL Pay example. For that, you do an HTTP request to one URL. You get a response telling you some metadata, who you're gonna pay, what's the minimum amount that it can be sent, the maximum amount that can be sent. And if you do another HTTP request, then you get a Lightning invoice from the service. We're going to look into code into that in a second. Quickly running through the standards. Roy talked a lot about WebLN. The goal here is we have a set of specifications for Lightning applications that facilitate the communication between the application and the user's wallet. So it's basically a JavaScript interface that any app developer can use to communicate with the user's wallet. Currently, it focuses on Lightning, but there's a lot of talk and an active collaboration going on to work on a general interface that also exposes on-chain capabilities, and maybe we will see something like window.bitcoin in any browser in the future. One thing to add is lsat.tech, which is describes it is the Lightning Service Authentication Token. LSAT is the short for that. So it's also a standard protocol for authenticating and paid APIs. So if you want to build an API that people have to pay for per request, this is what you really want to use. It's the solution for the forgotten HTTP for 2 payment required status code, and it defines a standard how a server responds with a payment request to a client, and how the client then provides payment proof to authenticate afterwards and basically to consume the resource. There is much more to that. All this base is super active in development. We heard Lightning Node Connect, but there's also things like /tags and everything that Synonym is working on. But let's look into some code. You can follow that on GitHub. This is the Git repository that you can that holds all the code, and I hope you have that also in the YouTube channel now. And we're gonna do two things now, two small applications, really tiny applications, but I think they give you an idea of how building web applications on the Lightning Network actually works and actually looks like, and maybe also some inspiration of what you can do. As a first step, I look into a Lightning guest book, just because this can be done. It's really a hard copycat of what amboss.space is doing. They have a billboard on their website, which is super cool. And it also happens actually that like sometimes in the 90s, a guest book was the first dynamic web application that I've written. So it's kind of fun to do that again, but now with Lightning. So what it's doing, it is a client-side application that uses KeySend to send messages to a node. So it's really just a simple static HTML JavaScript page that sends messages through the visitor's Lightning wallet. And what we use here as a requirement is it's really a static page, but the visitor needs WebLN, a WebLN wallet with KeySend support, which is kind of new. So right now that's an experimental feature in Alby. And maybe you also need a Lightning backend to actually read the messages. So let's jump over into code. And I have here my editor. The first part, let's close these here. We're gonna look into that in a second. So it's a really small application. Where's the HTML here? It's a node application. It's HTML. So it's a Node JavaScript application, or it's a Node Express app that serves this HTML more or less. And maybe we first jump into the browser and see how it looks like. And you can actually also follow it there on WebLN guest book. Really looks like the 90s. So what else? What all that it's doing? It's giving you an input field where we can say hello world bolt.fun rocks, and I can send this message. The wallet pops up. This is now Alby that pops up, wants me to confirm the payment. On Alby, I even can set a budget that I don't want to get bothered with that anymore. I press confirm, the payment is sent, and we have the message here in the guest book. The cool thing is it's really like a static page that sends the message through the Lightning Network to the recipient's node. And here in my example, I'm also loading the messages from the node directly. So there is no database or anything else involved here. So how does it work? We got the HTML here. I showed that to you already. Pretty boring. You just have the form with an input field here and a button and a send button. And we got a few lines of JavaScript code here. What we do is first we add an event listener once the form is submitted. we want to execute our JavaScript here. And then there's really just two things that we want to call. We want to call WebLN enabled to request permission to use the user's wallet. And once that succeeded, we then do a WebLN function call. In this case, we call keysend with the parameters that we want to pass on to the wallet. In this case, we want to send over a destination where the message should be sent to. An amount, in this case, it's a hard-coded, we just want to send 1 Satoshi. And we send over the message through the keysend protocol here. So this is kind of the message. Probably can think of it as an ID. So this indicates that to the Lightning network or to the Lightning wallet that this is a message that is attached as a record to the Lightning payment. So now you might wonder where WebLN is coming from. And because this is not part of our code here, this is what the user's browser brings with. And that depends on whatever the user is using. So for example, if I'm using Breeze will inject this object into the website that I, as a developer, can use it here. If I'm using Alby in my desktop browser, then Alby is injecting that object to be used here. And this is the nice thing. So I don't really need to integrate with one wallet specifically. I just integrate with the WebLN standard, and it's automatically interoperable with whatever tool the user is using. So that's Breeze, Blue Wallet, Alby, whatever it is. It can be also others in the future. So you don't have a hard login here, which I think, as an open web developer, I think is super important, and that's why I'm always emphasizing on that. So yeah, let's jump back to the browser real quick here. I'm removing that one here to do it again. Just sending a message. So what happens is the first thing is now we have the WebLN enable call, which is the first step. We request a permission here. Once the user confirms the permission, we actually request the payment. We've just seen that before. User confirms the payment again, and message is sent. So yeah, basically a few lines of code. You got a guestbook written, completely decentralized on the Lightning network. Could even imagine if you're now loading the messages from the user's wallet, maybe in the future, that would be something like really a web-based, Lightning-based decentralized chat. So yeah, check it out. And yeah, if you have questions, please post it in YouTube. I will get to that then. So the next one that I brought you here is the paywall. We just had seen in Breeze, sorry, what Roy was mentioning is for content monetization. And we have an example here. So as a disclaimer, I really don't like the word paywall because it somehow puts an image into people's head that they cannot access content, and there is a huge red bar that disallows people to use it, and you have to enter a lot of complicated data like credit card information and log into PayPal and whatnot, or make a subscription. So that's why I really don't like the word paywall, but for the sake of it, let's use it. I just think that with Lightning, we now have a programmatic way to completely have new user interactions and to completely envision new ways to monetize content besides this ugly paywalls that we might know. So yeah, what we're now going to do is we build a simple web application that requests a payment to access content. The the requirements is we have the app to do the payment, and we have a Lightning backend, or we have an LNURL pay backend, and the user needs a Lightning wallet. I'm going to do that in two options. First of all, we directly connect to a Lightning node to receive the payment details. And the second option is then we check out how to use LNURL pay, where you actually don't really have to, or your application doesn't even need to have an open connection to a Lightning backend. So you can reuse the protocol here. So back to the code. This is in the gRPC folder. gRPC because I'm connecting through Node.js to the gRPC interface of LND. For that, I'm using the LN service npm package, which is a nice, easy to use, quite low level library to talk to LND. I'm initializing a new LND object. For that, I need the certificate, the macaroon, like as authentication, and actually the URL of my Lightning node. You can configure those in environment variable in an .env file. There should be an example there. To see if everything is running, we quickly do a get identity call, which just requests the node ID, which does a call to the LND node and requests the node ID. And then we have two endpoints. First of all, one endpoint, like the index endpoint, that generates an invoice whenever somebody visits the page and requests a payment of 10 Satoshis. And the second endpoint is the authenticated endpoint, where we use the payment hash that we set in the cookie in the first endpoint, and we use the payment hash in the second to look up the invoice and check if it's actually paid. So how does it look like? Quickly starting the application here. When we started, the first thing that we see is the public key that I'm connected to. And if we head back to the browser, hurry up here. We got a super simple application, just gives us a button that again has some WebLN call, which we look into here. That's the front end. And we have a simple, quite similar JavaScript code. Once I click the button, I request permission from the user's wallet, and I'm initiating a payment. Once the payment is completed, we are redirecting the user, in this case, to a different endpoint. So again, nice thing is here, I don't have to see any QR code. It's really like a deep integration into the user's wallet. Requesting a payment of 10 Satoshis, again, setting a budget that I don't get buzzed with that anymore, and I have a success, which would be your paid content. Just to show you this option about in Alby as setting the budget, and also because the web developer doesn't have to care about that. Because I have now set there's the budget of up to 100 Satoshis on this website, it will send the payment automatically. So if I click here, the payment is done in the background and I directly see the success message. But we have one more thing that I want to show you, which is the complete static page, which I think is super cool because it really makes hosting these applications really easy. And this example that I had so far is you really still have a kind of a backend, a node connection. But we can also reuse existing protocols. In this case, we're going to use LNURL to do that and to request the payment through that. That means we don't even have to run this backend and this node integration. So for that, I really have the same application, small demo HTML. We have an unlock button to request a payment, and we have a bit of JavaScript code that looks a bit is a bit more code, but it's still quite simple. And one library that I really want to recommend to you here is the LNURL Pay library, because this is a really nice JavaScript library that wraps all the LNURL Pay calls for you. So you really just need to have one simple request invoice call. You pass in an LNURL or even a Lightning address, and how much Satoshis you want to send over. And it does the HTTP call for you, parses the JSON, and gives you an invoice, and also gives you some nice functions, for example, to validate the pre-image. And this is what we're going to do now here. First step, we're going to request the payment. Second thing is, again, we call webln. First, we request a permission. And then as a second call, we do the send payment. And here, this is now different to what we had before. We look at the payment response, where we get actually the pre-image from the wallet. And we can really directly in JavaScript validate the pre-image by comparing the hashes. So what the JavaScript is doing here, it is comparing the hash of the pre-image to the payment hash that is in the Lightning invoice. And if that validates, then I know the user, or at least the pre-image is correct. The pre-image validates for this payment request for this Lightning invoice. And my application, in our case, I'm just showing a success message here. So how does that look like? Let's go into the static folder. And because it's really just a static application, I'm serving it here on this port. Was it 8080? No, 8000. Same application that we got. And we have pretty much the same interaction. Web application requests the payment, my wallet pops up, I confirm the payment, and here I see the pre-image which we also validated or compared, and I see the success message. And because this is using LNURL Pay under the hood, so I can now also provide a comment, for example, that is sent along with the payment to the recipient. By the way, as recipient, we sent here a message to Ben, Ben at lnurl.com, and let's find rocks. Oops, I have to first reload to reset the state. So we have bolt.fun rocks in the code. We get the comment here, we pass it on, and we look here in the console, you will see the LNURL Pay HTTP requests that are done, which is first, it's getting the details on how to generate the invoice. You see that here. The second one is actually saying, okay, here's the callback. I want to send you 10 Satoshis, that's the amount is here in millisatoshis, and I'm passing along a comment. The response here gives me the payment request, which we use in webln to call the wallet. Wallet confirms the payment. And we, as an application, again, can check the pre-image against the payment hash in that invoice and to know that the user has paid. So what that kind of allows us to do is to, even as a static web application, orchestrate payments, and the payment flow goes directly from the user's wallet, from my wallet here, to, in this case, Ben's wallet without me needing access to Ben's node or whatever Lightning backend. Or the application doesn't need to have any access to Ben's Lightning node or Lightning backend. And we don't even know where he receives the payment. The application is just facilitating it. So there are no sensitive data. And the nice thing is, because of WebLN, we have this two-way communication between the wallet and the application. Again, here, we can also verify that a payment actually has happened, or at least we can verify that the pre-image matches to the payment request that we got from Ben's LNURL, from Ben's Lightning address. Yeah, I guess we are running a bit out of time. That's it so far from the code. And I would see if you have some questions. Please check out also the repository. Again, it is on my GitHub, WebLN demo. You have the different examples here. And if you have questions also later on during the hackathon or whenever, you can find me on GitHub, anywhere. I'm open. One thing that I would like to mention or would like to emphasize on is that we now have all these building blocks and puzzle pieces like the LNUL specs, WebLN specs. We have this JavaScript tools that I just showed. Really, the question is now how we can use those creatively and what we can do differently. So, for example, in my last example, where we had this comment that you can pass along, I thought this is not just a comment, but you could really have something like a it could also be used for an address field if you want to build a web shop or something like that. So the user, whoever buys something, really could use this field to provide an address where the product that is sold should be delivered to. And with that, you get the details in the Lightning node. And with that, you really just have a static page that can be published somewhere to basically do e-commerce kind of things. So yeah, we really have to use these tools and fields and whatever APIs that we have in a creative way. And that's why I'm also super excited about these hackathons, where this is all where the ideas are happening, right? So,
do the other non-static demos verify transactions too? I.e., it doesn't look like they do a pre-image check.
Yeah, good question. In the non-static one, the first one that I showed, the gRPC interface, there I'm actually not validating the pre-image, but because there is a Lightning connection to the backend, in this case directly to the node, I'm actually asking the node itself if the payment is done. So I just wanted to show this code too. So there is a bit of a different check in there. And you have two ways to do that, either directly asking the node if the payment succeeded, or basically just check the pre-image. The pre-image check is really useful if you don't have access to the node, like in the LNURL example, where you have the static page. It doesn't have any dynamic backend. It doesn't have a direct connection to the recipient's node. It only uses the connection of the visitor's node. And for that, we can use the pre-image check to validate the payment. That's generally the big question that applications have, is how do they know where to send the payment to, and how to verify the payment has happened. And there are different ways to do that. So, and yeah, these are two ways. Verify, as discussed yesterday, would be another way to do it.
We've spoken quite quite a lot about this Lightning economy, Lightning web applications over the past year. So I'm really excited that, everything is kind of like coming together now with the developments of Alby, with WebLN, and now this hackathon platform that we have to start creating things. And yeah, I'm really excited to see what comes out.
Very much. Yeah, that's the great thing, that we now can really use these web technologies and also have these libraries to build awesome user experiences, awesome user UIs, and actually focus on that too.
So. Nick H asked, do you have any project proposals besides the most invoices?
So generally, I like this idea of the value for value ideas, and I think this should be spread more across the web. One idea could be, or one interesting field could be, exploring that, how to use value for value payments on blog posts, on blog articles. For example, have a boost, like Breeze has it in the podcast player, how to have a boost button that people can integrate into their websites quite easily. The more often I click, the more payments I'm sending over, or the higher the amount is gonna be as payments. Just mentioning that because I think it's quite easy to get started with that, and because I would like to see that for my applications.
Value for value, right? Incentivizing the creation of content for people to learn how to use WebLN stuff, and people getting paid for it, right?
Yep, value for value.
Yeah. Value for value. I think that's everyone, when you're thinking through your ideas, I think that's a really good model to a really good lens to think about what Bumi said. Projects which give value and get value, because even the example for the most invoice, right? This crazy idea, most invoices. What is the value that the person's going to get from actually paying that invoice, right? That's something you might have to think about. So, and that's actually the tricky part, right? You could do a while loop, while true, and keep generating invoices. But what's going to incentivize someone to actually interact with it?
Right? To add on that, I really think what Johnson was also saying is you can also think about what user interactions that users typically do online or on websites could be connected with a payment stream now, which we couldn't do before. Right before, we couldn't really have a mouse click be connected to a payment in an open network. Now we can really do that. And I think there was also one more question that I see here in the chat, which was about what is needed to really stream sets, which is a super good question. The easiest thing is really just have kind of a loop, a predefined loop that sends payments periodically. Obviously, you might want to have a bit of so the most simple thing is to have a timeout to say, okay, every 5 seconds I'm sending a payment over. This actually could also be done with requesting an invoice from LNURL or requesting an invoice from a Node backend. It's just you have to consider the latency there, because it takes a bit to generate the invoice, to get it back, to send the payment, and so on. So this is a bit of a hack. You could also do some kind of a debouncing here to batch certain transactions up. Say the user does 10 clicks, and after 10 clicks, you sum that amount up and then do the payment. Keysend could be an option where you don't need an invoice. This is what the podcasting value for value podcasting apps are doing, that they're using keysend payments to initiate those payments. But it's really just up to you as in JavaScript how you call Lightning and how often you call Lightning functions.